Today we will be working out a chi-squared test for standard deviation. Okay, so when you're analyzing numerical data, sometimes you need to draw conclusions about the population variance or standard deviation. Assuming that the data is normally distributed, use the x-squared test for variance or standard deviation defined in the equation x stat equals n minus 1 s squared over standard deviation squared to test whether the population variance or standard deviation is equal to a specified value. So in this equation, n equals sample size, s squared equals sample variance, and the standard deviation squared is the hypothesized population variance. So this x stat follows a chi-square distribution with the degree of freedom equaling n minus 1. Okay, so selecting from a sample size of 25 cereal boxes, assume the population standard deviation is equal to 15 grams. In order to see if the variability of the process has changed, you need to test whether the standard deviation has changed from the previously specified level of 15 grams. So I am interested in determining whether the standard deviation has changed from a previous level of 15 grams. And to do this, I will be using a two-tailed test. Step 1. State the hypothesis. The HO is equal to standard deviation squared equals 225, or standard deviation equals 15 grams. The HA is standard deviation squared is not equal to 225, or standard deviation equals 15 grams. Step 2. Find the critical values. To find the critical values, we are using a 0.05 level of significance and 24 degrees of freedom. So our lower critical value is 12.4012, and the upper critical value is 39.3641. Step 3. Calculate test statistic. The test statistic, as we saw earlier, is calculated by n minus 1 times s squared over standard deviation squared. So the n equals the sample size, the s squared is the sample variance, and the standard deviation squared is the hypothesized population variance. This brings us to the value for the chi-squared test statistic, which is 33.4176. And the p-value for this, which also comes up on the calculator, is 0.0956. So we'll remember this for later. So this is our graph. So you can see that the area 0.05 has been split on both sides of the two-tailed test, so it's 0.025. Both of our critical values have been graphed, 12.401 on the left side and 39.364 on the right side. The blue shaded regions are the areas of rejection, and as you can see, the x stat falls between these two areas of rejection, so we are going to make the decision in step 4 that you are not going to reject the null. We're not going to reject the null because the chi-squared test statistic falls between the critical values, so you do not reject. Also, because the p-value is greater than alpha, you don't reject the shady hoe. So this is 0.0956 is greater than 0.05. Step 5 is to summarize all of this, and in conclusion, there is insufficient evidence that the population standard deviation is different from 15 grams.